All right, team. So, exercise 15D. Assuming now you've got a general idea of what a precedence table is and how to read a scheduling network, or essentially activity network, in this exercise, and I would probably want you to spend more time over the weekend to practice 15D, because then when we go to 15E on Tuesday, it's somewhat easier to digest. Okay, so here we go. What makes this slightly different? This time, in your precedence tables or activity network, you will have the weight with them. So each of the networks will now have a number, and your job is to use those numbers, kind of similar to Dijkstra's algorithm. You're going to calculate the best or most effective, I guess, value or time. That's what you're doing in this exercise. Okay. Now, in order to do that, there's a couple of new terms that you're going to need to learn, and this piece of information is going to be key. Now, I'm just going to highlight some of the keywords that you're going to get used to. EST means earliest starting time. So remember, this is all to do with scheduling. So it's what's the earliest time you can start this activity, whilst LST means the latest. So what is the latest starting time? And you'll see what I mean when we start doing a couple of problems. Then there is what we call a float time. A way to think about it is, say if I drew two scheduling activities. Let's say you're splitting the job and you're baking a cake. One person does the flour and the mixing, takes them, say, 5 minutes to do. The other person's activity is to prepare the oven. So they just need to turn on the oven. And that, I'll do T for turning on the oven. And that takes only 1 minute to do, right? Say that was the case, which is independent of each other. Let's say that after you've mixed the flour, you need to, wash your hands, okay? This person washes their hands for 2 minutes and they're done. This person doesn't need to wash their hands. They are done, okay? So I'm just going to do it like this. So wash their hands. Takes them 2 minutes. What you can see here is that, well, technically I can draw a straight line actually. I'll draw a straight line for T. So what you see here is there are two activities here. One person's doing the flour, then they wash their hands and they're done. Listening? The other person just needs to turn on the oven. Takes them 1 minute. Now, let's see, how long does it take for this entire activity to be done? What's the longest time that's needed in this particular activity if we had to count it? What's the longest time? So from the starting point to the finishing point, how long does it take overall? If you had to account for a time, how much time would you account for?
7 minutes.
7 minutes. Because it takes, the longest time that it takes is 7 minutes for this person to finish it. Even though it takes this guy only 1 minute, it takes 7 minutes overall to ensure that's the minimum time allocated so these people can finish their job, right? Now what's interesting is in that 7 minutes, this person will continuously work. But the float time, this person doesn't have to start as soon as the other person starts. They can start how long? Much after. What's the float time that they can start? See, if it's 0 to 7 minutes, what's the latest time this person can start?
6 minutes. 6 minutes.
Yeah, that was the logic, right? So when you're dealing with this, you're going to learn what we call latest starting time and earliest starting time. So earliest, yeah, he can start at 0, right on the dot. He can start with the other person. But we also know the latest starting time is 6. And you'll find that that's what these tables I'm going to show you. Notice that they have two boxes. One box is for the earliest starting time, and the other box represents latest starting time. So in the example I just did just now, that's indicating that if I were to draw a box for T, person at T, they have the option of starting at 0, or they can start at 6. And the reason why you knew is because I gave the weight of 1 here. That was a duration of 1, and you knew that at this point here, they will finish at 7. Sorry, 7. That's how long it takes. They finish at 7. Okay, so that's what you're going to be learning, how to read what those boxes mean, how to find duration, how to find earliest starting time, how to find latest starting time. That's where it starts to get confusing. Okay, so when you start to solve the problems, that's what it is. But I just gave you a very simple idea of scheduling that kind of embeds it together. So you can take this scheduling, now you can change that into a precedence table with what's linking to what. So in this case here, we've got F starts on itself, and we've got T starts by itself. T doesn't require anything, but we know that W requires that F needs to finish. Okay? Hey, that looks like for the win. FTW. But anyways, there you go. So that's an example of a precedence table. What we're missing here is the weights. So if we move into what we're doing today, what you see here is a precedence table. Okay, so example 8, you've got a precedence table, same thing as what you did before, activity. You've got a predecessors. Your aim is to draw this network with the weights. Okay, so that's the first skill, to draw this network with the weights. Okay, so let's try this. Let's try this together. Here we go. We should have 1, 2, 3, 4, 5, 6 edges in total. Let's draw them out. Here we go. We've got A. Edge A is independent, doesn't have anything connected to before. Has a weight of 6. So I'm going to write 6 there. B. Totally separate. Shh. Listening. Thank you. You got B, which is 9. And then C connects with A and B. So if I were to do this, likely C must have a dummy. There has to be a dummy connecting B back to C. Okay, so this is going back to what you did in 15C. 15C. Okay, and then now we're going on to D. To draw D, D also relies that A and B finishes. So that means you can connect D. Watching U12s, thank you. So you can see that D also connects with after A, and it also connects from the dummy after B. Then D begins. Yeah.
Wouldn't for the dummy, are we going to do the away and C would have to be at the B? Then you're saying also that C is going. Oh no, sorry.
That's good. That's good. You're engaging with it. That's good. All right. Listening. 12s. Thank you. I'm just quickly going through this so that you've got a feel of it. Okay, so we've got activity network. A, weight of 6. B, weight of 9. Remember, dummies have a weight of 0. Okay, so the dummy activities have a weight of 0. Make sure that you don't add them on, but you do need to draw a line for them. And then lastly, we're moving on to E now. E relies on D. Okay, so E is connected to D. So here we go. We can draw E out this way, drawing all the arrows correctly. D has a weight of 7, and then C has a weight of 8. Okay? How do we finish it? We can see that F relies on C finishing and E finishing as well. So what I can see now is if we looked at the end, we knew that F, C, and E is meant to connect to get to F. That means I can actually finish this off by doing this and say that is E and this is F. See what I'm doing there? So that now describes E and C needs to complete before F can finish. E needs to be done after D, and D can be done after B and A is complete. Okay, so that's describing the precedence table. So the first step, A, draw the activity network. I've done. I need to put in the weights. F is 12. E is 10. Okay, now, one of the terms I haven't taught you yet, they call it a critical path analysis. So, in each and every one of this now, your job is to understand what is a critical path, right? I'm going to quickly show you in each and every one of these networks here. Here's a quick network. What is a critical path? A critical path means that your float time is 0. So I'm going to write it again. Float time equals 0. This is the same thing as a critical path. Now, why do they call it a critical path? Reason why they call it a critical path is because if you have a float time of 0, it means that you don't have flexibility. It means that unlike before, you know how I said T can start at any time? I asked you when can they start? You said 6 minutes afterwards. They could have started any time in between. With a float time of 0, they can't do that. It means as soon as you finish, so for example, this one, they can start earliest after 6 minutes. Latest time they can start is at 6 minutes as well. This person cannot start any time later. It has to be at 6. Then you get to here, same thing. After the amount of duration, which we don't know right now, but going from 6 to 9, clearly the duration has to be 3. So 3 minutes here, this person has to complete it in 3 to start exactly at 9. Because the latest time that they can start is 9. We call this a critical path. So edge A is considered a critical path because it has a float time of 0. It means that you can't screw it up. This would be important that this person has to finish on time. Whereas the person who doesn't have to finish on time, for example, here, okay, so edge D, if you have a look at edge D, D doesn't have to worry. They can start 8 minutes after the activity has begun, or the latest start time is they can do it at 13 and they still finish on time. Okay, so this is what they're trying to say. Activity D doesn't have to worry because they've got a float time of 13 minus 8. This is the difference between them. 13 minus 8 gives them a buffer. They've got a buffer of 5 minutes. That means they can start 5 minutes after 13, or they can start 5 minutes after 8. Okay, now, in order to calculate this, you need to know how long the duration is. Okay, because if I said 5 minutes, you can see 13 plus 5, it's way too much now. And 18 plus 5, I'll make it. So your activity here is to find out what is the duration for D. Okay, and the best way to figure it out, 15 minutes is the latest starting time to finish. 8 minutes is the earliest starting time for D to start. So in total, there's a distance of 7 right there. There's a distance of 7, but we need to know what the duration is in order to make sure that 8 gets to 15 and 13 gets to 15 on time. So logically, 15 back to 13, what should the duration have to be for D? 2. Okay, so this is what you're doing in this activity here. You're working with ESTs, LSTs, critical pathways, float time. That's what it's about. That's what makes this interesting, or at least hard. As the networks get bigger, for you to work out duration, starting time, earliest starting time, and latest starting time, that's what makes it tricky. Okay, so in your exercise, what they'll start off by doing, they'll give you some simple ones. They give you a pathway and they say, shh, this is EST, this is LST. Okay, so essentially they're saying from here to here has a duration of 4. So activity P has a duration of 4. So if the latest starting time here is 12 and here is 8, we can see that's minus 4. Whilst over here, 8 plus what? To get to P, I know P then has to be 12 because there's a plus 4 duration. Okay, so in each of these activities, that's what you're doing. You're going through EST, LST. The reason why this is going to be tricky is when you start doing these kind of problems here. Okay, so they'll ask you, what is the duration of activity A? What is the critical path? And like I say, critical path was when the float time 0, and I can see this is your pathway. 6, 6, 9, 9, and 15, 15. These people here, so activity A and activity C are very important. Those people who are assigned for activity A and activity C cannot screw up.